the University of Arizona Bio5 Institute, we bring together hundreds of multifaceted experts that include world-class bioscientists, engineers, physicians, and computational researchers. This team science approach is designed to ignite creative solutions to the many complex biological challenges facing our families and communities, and has resulted in disease prevention strategies, promising new therapies, innovative diagnostics and devices, and improved food sustainability.
Hello and welcome to another episode of Science Talks, a conversation hosted by the University of Arizona's Bio5 Institute. My name is Lisa Romero. Infectious diseases are the leading cause of death in developing countries and ignite grand challenges like pandemics. Bio5 researchers are working to develop better prevention, diagnostic, and treatment strategies to decrease the global burden of these diseases. Today, I'm happy to be joined by Bio5 member Dr. Deepta Bhattacharya, who is a professor of immunobiology and associate professor of surgery, genetics, and cancer biology. Dr. Bhattacharya merges stem cell biology and immunology to understand the development of white blood cells and to devise novel strategies to fight illnesses such as COVID-19, influenza, and dengue virus. Dr. Bhattacharya, thank you for being here today.
Thanks for having me on, Lisa.
Yeah, I've been excited to talk to you for some time, as have many others. We'll get to in a little bit how you become the man of the hour, this calming voice of reason in our heads throughout the pandemic. But I wanted to kind of start a little bit earlier in the journey and just before we talk about your current work, just talk a little bit about your path and how you got here. I know that science is in your blood. I know that I believe your father was a retired University of Arizona professor of pediatric cancer, and I know it sort of is an all in the family thing for you all. So just would you mind talking a little bit about that journey and if science really was in the blood and you knew all along, or just kind of how you got to be where you are today?
Yeah, and I know that there are some people who are planners and think, okay, this is what I'm going to be doing with my life. And I cannot, in any honesty, actually say that that was the journey for me. So I come from a background of mathematicians. My father was a mathematician, is still actually. He's emeritus here and at the U of A. And really my older sister was very much mathematically inclined as well. So she actually works for the Department of Defense as a mathematician, and a computer scientist. And, I always felt in some ways like the black sheep of the family because it just didn't come that easily to me. It came easily enough to the extent that you're in elementary school, but then it gets harder. And then I started to think, well, maybe this isn't really quite my strength. And particularly as we got into college further and further, it just stopped making nearly as much sense to me. And I think that's one of the things that you recognize from mathematicians is that the numbers are almost like a language to them. And I just didn't feel that intrinsically. And so, how did I actually end up in this? It's a strange journey. Really, I think I was really much more interested in sort of hard chemistry. And maybe some computer science, mainly because I like playing video games more than anything else at that point. I went into to college. I went to Indiana University as an undergrad. And I was thinking that I was going to do probably chemistry. But then oddly enough, what sort of had this weird language requirement where if you're going to be a chemistry major, you could only take either German or French or Russian as your foreign languages. Whereas I had 4 years of high school Spanish, I'd taken some more in college, and it seemed a little silly to me. And so then what I did is actually change my major from chemistry to biochemistry. It's still administered by the same department, but they actually allowed Spanish as a foreign language.
That's so interesting.
And so then that started to get me to start taking some more biology classes as part of the requirements for the major, alongside all the hard chemistry I was wanting to take anyway. And I started to like it. My teachers were good. It was interesting. I liked evolution. I liked molecular biology. I liked genetics. And then ultimately it came to sort of a difficult decision when I decided that I was going to go to graduate school, which is what am I going to go to graduate school in? And ultimately when I started reading the descriptions of the different schools and what they were doing, I just found myself being pulled and drawn more into the biological sciences. And so then I got in as a student at UC Berkeley. And that's when I first started to get into immunology.
That's such an interesting story. I kind of love those types of stories. Like you said, there are just those people that know from an early age, but I really like that one, how you had to switch your major because you didn't want to take another language. And that's how we got you here today. That's pretty exciting. That's
Yeah.
very cool. Well, I mean, today, as evidenced by your lengthy biography and all your accomplishments, you've gotten to this place where your research really, merges those fields of stem cell biology and immunobiology, and talk about that a little bit, how the lymphocytes, white blood cells, the development of that, how you look at that in terms of translational strategies, for these infectious diseases, and just sort of how you, again, kind of then where you came to after school led you to this, and some of your current projects.
Yeah, and again, this is, I feel like it's just sort of this circuitous route to how it got me here, because again, none of this was especially planned. After I finished my PhD, I just wanted to do something a little bit different, and for, again, because my wife was still in graduate school at that point, I wanted to stay in the Bay Area, and I had throughout graduate school read papers by Irv Weissman, who is a professor at Stanford, and really one of the leading voices behind stem cells. And around that time, there was sort of ballot initiatives to try and get state money to do some regenerative medicine work. And Irv was one of the leading voices behind that. And really, I just, I decided that I would like to try and do a postdoc in his lab if he would have me, simply for no other reason, because I just thought that the stuff he did was cool. It wasn't any sort of like forward planning or anything where I thought that this would put me in a good position for my career. I just thought it was cool. That's it. And so what his lab primarily did were stem cells of the adult type of stem cells, hematopoietic stem cells. So these are the stem cells that we all have. They live in our bone marrow, and they're responsible for regenerating all of our blood cells, red blood cells and white blood cells. And because those cells die pretty often, they need to get replenished, and it's the stem cells that do that. And so I did a lot of just basic work and understanding how stem cells give rise to some of the immune lineage cells, which are part of your white blood cell system. After that, then, things went pretty well in my postdoc. And so, again, I felt like I wasn't especially wedded to an academic career per se, right? If you live in the Bay Area, there's plenty of opportunities. But what ended up happening is I got a job offer at Washington University in St. Louis out of my postdoc, which to me seemed, again, sort of the best opportunity to continue to do some cool stuff that I felt like doing. So again, it was not like it was like this, that I was on this straight, narrow path down this career. And so then one of the things that I recognize is when you start an academic career, it's difficult to carve out your own niche. And I thought that the best way to do that probably would be to merge some of the things that I did as a graduate student, which is basic immunology, how do antibodies get made, along with some of the stem cell stuff that I had done as a postdoc. And it took me a while to figure out how best to merge those things, but that's really how I came to this in the first place, and why we sort of merged two fields that superficially don't seem to have a whole lot to do with each other.
I think you probably entered that scene at such a remarkable time too. I mean, this idea of regenerative medicine and is starting to be discussed so much more, and is really part of the scientific conversation today. But I know that it was not always like that. I'm sure with your sort of mentor in school, that a lot of people probably found that thinking very novel. So I think that the timing is very unique probably as well.
Yeah, I mean, I caught it at the right wave, I suppose. I mean, right around the time that I was a postdoc, the International Society for Stem Cell Research came into its fruition. And now it's a sort of a thriving professional organization that's devoted strictly to stem cell research. But at the same time, I think there was a lot of excitement, but also a lot of controversy around these cells too at that time. I mean, there were some restrictions around embryonic stem cell research. And then all of a sudden they came as an alternative, induced pluripotent stem cells, I mean, which later led to the Nobel Prize for Shinya Yamanaka. I mean, it was a really exciting time to be there. Groups all around the country were figuring out protocols of how to turn pluripotent stem cells into cell types of interest, like beta cells, liver, retinal cells. I mean, so really fascinating things where people were sort of merging the basics of developmental biology, things that we learned through decades of just basic work, and then applying that to stem cells and then being able to turn them into whatever you want. And so I think that to me was the really interesting and critical thing. Whereas I'd sort of worked in this adult stem cell field of, how do blood cells get made? When I started my own lab, we started to move over more to the pluripotent stem cell stuff, because then it's only your own imagination that constrains you, right? You can make whatever you want. And so that's where I started to think about what can we do with these cells that sort of merges the things that I've learned during my training. And then we started to think about, okay, well, how do we actually turn these stem cells into antibody producing cells? Because what we certainly know is that some vaccines work great, others don't, right? We still don't have an HIV vaccine. And yet what we know is that there are some people who, mainly through fortuitous chance, are able to control the infection without any antiretrovirals, mainly because they make these crazy antibodies that, a standard issue person is not going to be able to make. And so then we started to think about, well, for the diseases that you can't vaccinate against, what's the alternative? And then we thought, well, can we actually synthetically build immunity? If a vaccine won't do it for you, if a vaccine isn't instructing your immune system in the right way, can you actually provide the cells that would confer immunity? And so that's then how we sort of got to this space here, where we're still very much interested in the basic biology of what it takes to make a good antibody response. And I would say that 75–80% of the lab is still working on things like that. But then that also then gets plugged into some of the workflow of the people who work on stem cells and saying, okay, here's what we learned in the basic biology. Here's what needs to happen to be able to make a good antibody producing cell. Can we now build that into our workflow and then coerce those pluripotent stem cells to do just that? So it's sort of like a fun project. And it's been of great interest. And, I would say that, again, pre-2020, I'm not sure that there was all that much interest in infectious disease. Certainly funding has been great, right? But all of a sudden, some things happened in 2020 that changed the mindset of a lot of people.
A few things happened. Yes, for sure. That's what I was gonna say. I, wish your lab had finished this project before 2020. I think we all do. But you mentioned roughly 80% of the lab is still focused on that, which is really incredible. But let's talk a little bit about, I guess, the 20% that had to shift. I would argue probably it was a little bit more than that in the past 2 years. You pivoted the word of the past 2 years, I guess, because you had some of this background in technology and expertise and collaborative environment that was needed to sort of take on this pandemic. And you talked a little bit about antibodies, but I know you teamed up with a lot of partners across campus and across the states, and you worked together to develop this COVID-19 antibody test, basically, in like 24 hours. A little bit of an exaggeration, but not much. No small task, and you were just asked to kind of quietly do that. But and adopted statewide, and it became the gold standard, and really, I think, got Arizona and the University of Arizona out of the gate early, and remarkable effort that I know you were a big part of. Do you want to talk for just a minute? And I know you talk to everybody about the pandemic all the time, so I don't want that to be the whole conversation, but I think it's worth talking about that effort and anything that's sort of come out of that at this point.
Well, yeah, I mean, I think the advantage from our standpoint was that it actually wasn't that much of a pivot, really. I mean, I talked about the stem cell stuff before this, but really, as I said, I mean, the majority of the lab still works on basic immunology. And we study viruses and antibody responses to different viruses. And so, the family of viruses that we've probably done the most work on are called flaviviruses. So that's West Nile virus, dengue, Zika, Japanese encephalitis virus. And, again, from the perspective, I think my virology colleagues would probably have a heart attack if I said this, but again, from the perspective of an immunologist, virus is a virus, right? In terms of what we do with it. We're really more interested in how the host responds once the virus infects. And so there are certainly some similarities between the flaviviruses and SARS-CoV-2. They're both RNA viruses. They both mediate acute infections. And so a lot of the workflow tools and techniques and all these kinds of things were really already pretty well established in my lab. So I would say that it wasn't actually very much of a pivot at all, if you look at it from that perspective. On the other hand, everything that we've done up until this point was pretty basic, stuff you do in the lab. And so, when it became clear, I'd say late February, early March or so, 2020, I started talking with Janko Nikolic-Zugic, who's my department chair, about what we could do, right? Because at that point, it was clear that it wasn't going to just be geographically constrained to certain places. It was going to get everywhere, and it was going to come here, and we knew it. And so all we really wanted to do at that point was to be able to contribute in some way. Janko's lab also studies viruses. They look at it more from the T cell standpoint. It's a different immune lineage. And we just wanted to be able to contribute in some way. And so we started talking to some of our physician scientist colleagues at Banner and UA College of Medicine about making sure everything was in place so we could collect some samples from people who unfortunately landed in our ICU and help just contribute in some way to help us understand what it is that makes people really sick. And so part of that then, so we got a pilot grant from Bio5 to actually do some of that work. I'm sure you know that. But what happened is that word of that got out, maybe because of you. And basically our intent really was just to, test a handful of people just to make sure for their antibodies, just to make sure that they really did have COVID-19 and not something else. That was really our only ambition at that point with respect to what we were going to be doing. But then again, word of that got out. And then Amanda Morris at the Arizona Republic picked up on that story. And then that story then piqued the interest of some key governmental leaders. Clearly, I never really found out who that was, who then came back and then talked to President Robbins about whether or not we'd be willing and able to expand that. And so I'd say that after all that, what eventually happened is we kind of got voluntold to expand up that effort dramatically, because again, we were planning to do a few dozen of these tests. And then we were talking about maybe a few thousand for people on campus. And then that became 250,000 for the state. So that's not something, and I really want to make this clear, is that that's not something that one lab or even two labs can do. We don't have the capability of doing that, particularly when we're talking about doing clinical tests. We didn't have the background for that. And so all of that, I think I get way too much credit for that particular test because, what happened was then, Dr. Dake, Michael Dake, who's SVP of UAHS, sort of gathered together this amazing team of people who had all sorts of different expertise, from people who knew how to deal with regulatory issues, Office of General Counsel, just to make sure that everything we were doing was on the up and up on the legal side. And then Ryan Sprisler's team at the UAGC, who had a CLIA certified lab where they could actually run these tests. Matt Kaplan to be able to build up the robotics. And then, really, if you look back at it, take us a big step back. Our role on the development of those tests was very small in the grand scheme of things. I mean, it was just such a huge team effort. And I think that, when you look back at that effort, I mean, it's just so obvious that the whole is so much greater than the sum of the individual parts, because there's no way any of us could have done this alone. So I think, that it's almost laughable how modest our ambitions were at the very beginning, because now you see what we were able to do. And again, because of all this effort that people put in, we are at the forefront. We learn things much more quickly than other people who don't have this infrastructure built up.
Yeah, I think I will not claim the responsibility for putting you in the middle of the media frenzy, even if I did play any part in that. because I know it's been a lot. It's been pressure. It's been like, the voluntold I think a lot of us have been voluntold a lot over the past few years, but I think you definitely are among the highest ranking of those being voluntold. But I just, I want to take a minute literally and just say thank you though, because it is not minimal, because the scientific maybe pivot, wasn't as much as, those on the outside could probably understand, but you went above and beyond that. And I think because of your nature, because of, I'm a science communicator, and because of the way that you are able to translate your work and the work of the greater good at the university to, a greater audience that was really desperate, I think, for, a consistent, calming, if you will, voice of reason with facts. And, I think you became that voice. And so, first of all, thank you for that. But I know that has taken a lot out of you. I think you have been on virtually every, definitely statewide and local, but almost every national news medium out there. It takes a lot, doesn't it? It's a whole full-time job on its own.
Yeah. And I think this is one of the really important things now, again, to look back retrospectively, is that none of us are trained to do this. Well, none of us. I mean, we're primarily trained to do science, how to conduct experiments, how to do good experiments, how to interpret the data. That's really what we're trained to do. We're not trained to talk to the media. We're not. And so I think at the very beginning, I would be almost sick with nervousness every time I had to do an interview with someone, because I didn't know what I would say. I didn't it was just such a terrifying thing for me to get up there and have to talk to someone who, could use really anything that I said in whatever way.
Yeah.
And so that made me extreme, you can check with my wife on this. I mean, I would be sick with nerves leading up to an interview. And so then, but then what started to happen is that I think I recognized that a lot of the science journalists, I mean, this is not like political reporting, right? They're not looking for gotcha moments. They're trying as best as anyone else to try and help communicate the facts to people. And so then you start to recognize that we're all sort of on the same side here. And then that started to bring my nervousness down a little bit. And then I think I guess I just learned that, you really have to assess the situation given your own expertise and background and call it like you see it. Because there were definitely times where I was confused by some of the public health messaging coming out of the CDC. I still am sometimes. And at the beginning, I felt a lot of pressure that I had to conform to the party line, but at this point, for better or for worse, I don't feel that way anymore, right? I'm an immunologist. I'll call it like I see it from the perspective as an immunologist. And over time, then what's happened is I sort of built up relationships with a lot of the reporters. We know each other well. And it becomes a lot less stressful to be able to talk to some of these people about what I'm seeing. I think one of the key things that I've learned stylistically, and you mentioned this, is that I don't come at this from the perspective that this is going to be too complicated for people to understand, right? If it's complicated, then it's really important that you make it understandable rather than gloss over the facts and say something inaccurate. My experience has been is that people who are actually reading the interviews or listening to the interviews with me are trying to understand. And it seems like the appropriate thing is to speak to them like they're adults, good or bad, and explain why I'm thinking what I'm thinking with the proper level of uncertainty. And we've all gotten things wrong during the pandemic, but it's really important to explain why you think the things that you're thinking. Because again, I felt like a lot of public health messaging at the beginning was just sort of like, preparing people for the worst all the time. But, even when I don't think that was actually warranted. And so, I've just tried to call it straight, and the style has worked as best as I can tell.
Yeah, I mean, I think you're right. I think the honesty, your honesty shone through, whether you knew all the answers or not. And I mean, I think also your nature, I mean, maybe you were nervous as heck, but you went on and you were honest, and you presented facts, and you were optimistic to the degree you felt like you could, give people some hope or some alternative thinking, I guess. And sort of the world is ending, which it felt like, many times. So, but that's really a gift, and you know, you are very modest, but thank you for, you know, all you did and all you continue to do, both, you know, from just the national position of needing that sort of calming force, and definitely how you represented, you know, the University of Arizona. You know, we talk a lot about, you describe sort of how the infrastructure and the expertise, the collaborative expertise was there to create this, you know, large scale response and try to dive in. And, you know, this idea that the pandemic has been, you know, such a horrible thing, but really from a perspective of a university and in, at least in my position from a Bio 5 perspective, has been a really important story for us to tell, because, you know, you can kind of make people understand why it costs millions of dollars to have a facility that processes a certain thing, or a piece of equipment that does X, or, you know, a world-class scientist that knows how to do this. But the picture doesn't really come into play, and this made it all come into play, and it created this picture of, oh, all of this money, all of these years, all of these pieces have come together to support this infrastructure that's enabling us to quickly respond and robustly come up with solutions. And so you know, it's been an interesting, again, as a science communicator, and now all you can claim that title as well. You know, it's been an interesting story to tell, which is kind of cool in a way.
It is, you know, and one of the things that I say is, you know, I moved here from Washington University in St. Louis about, I guess 4.5 years ago or so. Oh boy, it's coming up on 5 years almost now. And, you know, and that's one of the, you know, it's one of the top institutions, particularly for my field, you know, in the world. But I can tell you with certainty that they wouldn't have been able to do this. They haven't been able to do this.
Yeah.
And so, you know, I'm proud to be here, I guess, is the bottom line. You know, I don't think I would have gotten the chance to be able to be part of this amazing team anywhere else. And so, yeah, it's been a rough ride for sure in the pandemic globally. But I think it's given the U of A a real chance to shine their colors.
Yeah, agreed. And thank you for being the one that held that flag most of the time. We really do appreciate that a lot. And I in particular, as my Twitter feed exploded over the past couple of years, always looked forward to your tweets to calm my nerves a little bit. So I know I'm not alone in that. But really appreciate your time, all you've done and all you continue to do. I hope you'll come back when the pandemic is a kind of a footnote, I guess, in history, and talk more about what you're working on next, or what this work is leading to after that pandemic. And we're really looking forward to all the innovative things to come.
Okay, thanks. Looking forward to it, Lisa.
Yeah, so thank you for joining us today, and thank you to our listeners for joining us on another episode of Science Talks. For more information, please visit our website at bio5.org. And from all of us at the Bio 5 Institute, we'll see you in the next episode.
Thanks to our listeners for tuning in to another episode of Science Talks. Continue the conversation with us next time as we learn more about the amazing science happening at the University of Arizona's Bio 5 Institute.